Mr. Ejiofor starting up. Just looking at the C to B webinar. If you can actually see what's going on, or sorry, actually watch the video, please let us know by actually saying yes in the comment section in the chat. Looking at the C to B webinar. Clearly, we've got 3 viewers already. So I'm going to obviously be going through the paper with you, year 11. Time is obviously running short now. We've got 9 minutes before we begin. So obviously start getting some water. Anything you kind of need to keep you going for the next 2 hours. Text your friends, let them know. So 7 minutes before we start the webinar. 7 minutes. Going to give you some quick instructions in a few minutes' time. Hello. Currently, I'm about to begin now. So, just a quick announcement to everyone watching out there at home. Just to quickly text your friends, let them know what's happening. Obviously, it's about to start in a few minutes' time. Hello. This is Mr. Edgeo4, obviously part of the maths department. If you haven't got a pack and you managed to forget it, print out a pack. Miss Fine sent the email. Type yes to let us know if you're involved in the chat. We're going to have moderators in the form of Miss Bajaria and Miss Rotherham who will be looking at all your comments, because I won't be able to comment on everything because there is a slight delay in terms of what I say and what you hear. Make sure you got a bottle of water handy because you're going to need it, because obviously it's a 2-hour session. Make sure you've got all your equipment. That includes a calculator, pencil, rubber, highlighters, pen, so you're able to actually answer the questions as we're going along and work through it. I will teach you some of the stuff and go through ways of being able to work them out, and expect you to have a go as well. There is a slight time delay, but obviously that will be actually aided by the teachers who are helping to moderate the chat, so they'll be getting at the same time as I'm actually saying it. Well, you'll be receiving it basically. And we will be starting in 2 minutes' time. There is a slight time delay, but obviously that will be actually aided by the teachers who are helping to moderate the chat, so they'll be getting at the same time as I'm actually saying it. Well, you'll be receiving it basically. And we will be starting in 2 minutes' time. There is a slight time delay, but obviously that will be actually aided by the teachers who are helping to moderate the chat, so they'll be getting at the same time as I'm actually saying it. Well, you'll be receiving it basically. And we will be starting in 2 minutes' time. There is a slight time delay, but obviously that will be actually aided by the teachers who are helping to moderate the chat, saying it. Well, you'll be receiving it basically. So 1 minute we'll be starting the webinar. 1 minute. That means make sure you got your packs ready. Text your friends, let them know we're starting. We've only actually got about 30 viewers so far, so we need to get a few more here watching the webinar. Get them down here watching it. The link is on the email that Ms. Fine sent to all Year 11 students. Make sure you got all your equipment, calculator, pencil, rubber, highlighters, everything that you're going to need to help you on this webinar. There's also chat to ask any questions. There will be teachers who are moderating it and actually letting you know and helping you with any questions you've got, so use them as a resource as well. Calculator, pencil, rubber, highlighters, everything you're going to need to help you on this webinar. There's also chat to ask any questions. There will be teachers who are moderating it and actually letting you know and helping you with any questions you've got, so use them as a resource as well. Calculator, pencil, rubber, highlighters, everything you're going to need to help you on this webinar. There's also chat to ask any questions. There will be teachers. So let's begin. Year 11 B2C webinar, 9th of February 2016. So we're going to start with question 1. It says, here's a list of ingredients for making 12 cheese scones. Ingredients for 12 cheese scones: 240 grams of flour, 60 grams of butter, 30 grams of cheese, and 150 milliliters of milk. Jason's going to make 30 cheese cones. Work out the amount of each ingredient he needs. So clearly ingredients are going to change in their quantity of what we need. So first of all, we're going to have to look at the quantity we've actually got at the moment and finding a factor of 12 that is also a factor of 30. Now, the easiest one to look at is actually 6 scones. So we're going to look at 6 scones. So clearly, from going from 12 to 6, we've actually had to halve it. So we're going to have to halve all of our ingredients. So that means we've got 120 grams of flour, 30 grams of butter, 15 grams of cheese, and 75 milliliters of milk. Excuse the handwriting at the moment. So at that point, obviously, we've got 6 games. We need 30. So we're kind of going to have to upscale. So how are we going to get from 6 to 30? We're going to have to times by 5. So that means that we're going to have to times all of these ingredients by 5. So 120 times by 5 is going to be 600 grams of flour. Then we're going to have 30 grams times 5, which is 150 grams of butter. And we're going to have 15 times 5, which is 75 grams of cheese. And 75 milliliters times by 5, which is 375 milliliters of milk. Remember to have your correct units there, because obviously they've got grams, 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 milliliters. Don't let them catch you out at the end. So here's a proper frank quick version that's already been pre-done. It's by Mr. Hegarty. So you can clearly see what needs to happen. Here's another actual route to be able to do it. Is obviously adding 12 again and adding 6 on for what this ingredient will be for 6 cheese scones. And then they just added it that way. So there's obviously multiple ways of being able to do this. Whichever one suits you, try it. So, as you can see, those candidates who first scored full marks either made an arithmetic error and scored B2. That means that you need to actually make sure you're adding up correctly and multiplying correctly as well. Okay, not making a silly mistake. So, going on to question 2 here, you can see we've got the actual terminology, which is obviously like terms. So we need to collect all the like terms first. And that's what we're going to do when we simplify. So we've got 4y. We can't actually see any other y, sorry. So we're going to leave that alone. So we look at 2x. We've got plus 2x and plus 3x. Okay, so then we've got those. And then also we've got numbers. So I'm going to highlight them in a different color. So first of all, then we can leave 4y on its own. Then we've got plus 2x plus 3x, which gives us plus 5x. And then we've got negative 3 plus 8. So if we're at minus 3, think about it like it was temperature. If you're at minus 3, add on 8, which means we're going positively. So it must be plus 5. So our correct answer is therefore 4y plus 5x plus 5. So the next question says factorize fully 9x squared minus 6xy. So we're looking for common factors that we can take out. The highest common factor of the numbers, we've got 9 and 6. The highest common factor of those numbers is 3. Now looking at our actual algebraic terms, we've got x squared and xy. So our common term there is obviously x. So we take x out. So that is what we can have outside. Remember that the opposite of factorizing is expansion. So we should be needing to get back into brackets. So we need to know what we multiply 3x by to give us 9x squared. So we need to have a 3 there, because 3 times 3 will give us a 9, and we need to have x times x to give us x squared. So we're left with our final bit here, which is 3 times something to give us minus 6, because we've got the minus here. That must be 2. And therefore, I'm just going to rub that out because it's a bit messy. My fault for planning wise. So it's 9 is 2, and we've got the y which we're missing, and that works. So next question, we've got expansion. So this is obviously the opposite of factorizing, like I said earlier. So we're going to do 4 times x, which is 4x, and then we're going to do 4 times plus 2, which is plus 8. Quite straightforward. If you see that question in the exam, you should eat it up. So the next thing we're going to look at is expansion of products for 2 brackets, which is a bit more complicated, but I'm hoping most of you will be able to do this. So we start off with x times x. That gives us x squared. Going to color coordinate this. Then we're going to do x times plus 3. Remember that it's plus 3. So it becomes plus, look at me now, look at what I've done. X squared plus 3x. Then I'm going to do a different color now. So we're going to do minus 5 times x, which is minus 5x. And then minus 5 times plus 3, which is minus 15. So simplifying that, we're going to be left with x squared plus 3x. Sorry, not 3x, that's wrong. That is wrong. Actually simplified wrong. Who knows what I've done? Let the moderators know what mistake I made. So it should be negative 2x minus 15. At this point, I'm just going to check who's actually in the room and how many viewers we've actually got. So I'm back. Here's a quick and frank way that you might want to copy down if you're not sure for what Mr. Heggett has done before. So, as we can see, there were errors due to candidates failing to correctly deal with the minus 3 and the plus 8. So that was on the first question where they weren't actually realizing that it was just 8 minus 3, and that some people probably had the answer of minus 5, for example. And then the same here, that candidates did a partial factorization, so they didn't find out the highest common factor to take out. So these were errors that we can see already. So you might want to have a quick go at some of these. Okay, I'm just waiting. My screen's actually frozen for a minute. I'm just waiting year 11 for my screen to unfreeze. Sorry about this. Oh, it's unfrozen now, I'm back. So, we're looking to factorize fully again. So we're factorizing fully. So we can see that we've got to look at the numbers first. Find our highest common factor. Our highest common factor is 6, and 10 is going to be 2. Can't go any higher than 2. So we can see that A is also common to both, so we can take out A from both. B and C, B is only in that one and C is only in the second term, so we can't take those out. So we need to do 2A times something, so 2 times to give us the 6. So we've got to do 3, and then we're left with actually the B, because we can have the B outside as one of our factors. So the next thing, we need 2 times something to give us 10. Remember that it's a positive here, so we're going to do 5, and then we also need to have C. Ready? So again, we're doing the expansion, the product of 2 brackets. So we're going to have, first of all, x times x, which is x squared. Then x times plus 7, which is plus 7x. Then I'm going to do in green. We've got minus 5. Remember, it's minus 5. It's the whole number. Minus 5 times x, which is minus 5x. And then minus 5 times plus 7, which is going to be minus 35. At that point, we have to simplify like we did before. So we're simplifying, and it becomes x squared plus 2x minus 35. Okay, so the next question asks us to simplify this and give our answer in its simplest form. Now, what I always tend to ask students to do is to separate our terms. So we can write m squared t to the power of 6, m to the power of 4, and t to the power of 2. So we know what we're dividing, so almost like we've got a 1 there. So 2 divided by 1 is 2. So we're left with 2. Remember, if we got m squared divided by m to the power of 4. We're actually subtracting the powers. So we're going to end up with m to the power of minus 2. Then we've got t to the power of 6 divided by t squared. So again, we're subtracting the powers, which is t to the power of 4. So just a quick one for you to quickly see how it, oh no, it's not on the next page. So we've got there d, which is factorised y squared minus 16. Does anyone know what this type of thing is? This type of actual expression and what it's going to lead to? Might want to say that if the moderators are in, it's maybe you might remember the acronym DOTS. Okay, you might remember that acronym. It actually is called the difference of two squares. So we know that our numbers which are in the brackets will have to be the same, and we're going to have y there, and as it's a squared number, because we're always looking for a squared number, negative squared number, we're going to have plus 4 and minus 4. Because basically what happens here is when you've got y times y, you've got y squared, y times negative 4 is minus 4y, then we're going to have plus 4y, and then negative 16. As you can see, the bits in the middle actually cancel out, so we're left with y squared minus 16. That's why it works. So here, you've got to remember that we've got h squared to minus 3, and then when we've got brackets, we're actually going to multiply the powers. So what you're going to end up with is h to the minus 6, which actually can be also rewritten as 1 over h to the 6, because it's reciprocal. So here's a quick, smart ways, quickly, nicely ways that's been done already. And there we go as well. So there's some information about what the examiner's for. Okay, so we've got the next thing about solving equations. So we've got to solve an equation. We've got x plus 9 equals 19. Remember, our key word here is the inverse. We're always looking to the inverse to find out what x equals. So we've got here x plus 9 equals 19. We want to get this 9 to the other side, into the right-hand side. Yeah. The only way to do that is to keep it balanced. So if we're going to get rid of it, which means take it away, we've got to do the same to the other side. So we take away 9 on both sides. So that leaves us with x equals 10. That was the inverse, the minus 9. So on this question, we've got 2y equals 17. That means that 2 times y equals 17. We just want 1y. So we have to do the opposite, which is got to do divide by 2. Again, you have to do it on both sides. So it becomes y equals 17 over 2. What's half of 17? That's 8.5. Now here, we've got w over 4 equals 8. So basic w is divided by 4. The opposite of 4, because we need to get w on its own, the opposite, sorry, of divide by 4, is times by 4. So we have to times both sides by 4. That leaves with w equals 8 times 4, which is 32. So here, we've got another expansion question, which you should be experts at by now. So we're going to do 3 times t, which is 6, and then 3 times plus t, which is plus 3t. And here is the full frank explanation from which was already done. So here we're solving question 5. We've got here solving another equation, 2x plus 3 equals x to the minus 4. So we've got to get, this is actually, again, we've got x's on both sides, we've got numbers on both sides, so we can do whatever we want this way. This way to do it though is to keep x positive. We really want to keep x positive. So as x is actually bigger on the left hand side, we're going to move this value, this actual x here, because it's only one x. So we're going to do minus x on both sides. So that leaves us with 2x minus x, which leaves us with x plus 3 equals minus 4. At that point, we need to get rid of the plus 3 on this side, so we've got to do the inverse. we've got to do the inverse. So we've got to subtract 3 on both sides. Now, a common mistake people make is that we've got x and they'll say, oh, we've got a minus and a minus equals a plus, so it's 7. It is not 7. You have to think to yourself that it is 4 degrees, minus 4 degrees. If it's going to get lower by 3 degrees, how can it be plus 7? That's going to be a lot warmer. So I also want you to think about that. So it must be negative 7. So B is solving for brackets x minus 5 equals 14. Now, this question here can be done a number of ways, but a common way to do it is because we've learned expansion, it's just expand the bracket. So 4 times x equals 4x. 4 times minus 5 equals minus 20, which equals 14. So we've got there now a normal standard thing that we're used to dealing with. So we need to get this minus 20 over here. So again, we've got to do our keyword, which I've talked about a lot, inverse. So you know in your maths lessons that people always tell you about the keywords. This will be the keyword of this lesson. So we've got plus 20 on both sides. So that gets rid of the minus 20 on that side. So we're left with 4x equals 34. Don't know why I stopped there. So at that point, we need to get rid of this 4. So it's 4 times x. So again, we've got to do the inverse, which is divide by 4. So we're left with x equals 34 over 4, which I'm going to actually do, because you might get this on a non-calculator question. You might not have a calculator. So the easy thing to do at this point is to divide both by 2, because they're both in the 2 times tables. That's why you can divide them both by 2, because they're both in the 2 times tables. It's 34 divided by 2 is 17. 4 divided by 2 is 2. Again, 17 divided by 2, we said half 17 is 8.5. Done. We've done it. And that is a cleaner way of being able to explain it. So we're now going to move on to question 6. Now, question 6 obviously involves integers in terms of looking at inequalities. And again, my computer has stopped. Just wait in year 11, 1 second. Perks of modern technology. So we've got here n is an integer, and n can be, we actually has to be greater than or equal to minus 1, but less than 4. List possible 4 integers. So possible 4 integers. So it can be equal to minus 1. They tell us that. Excuse me. So that could be minus 1. Then we can have 0. We can have 1. We can have 2. We can have 3. But we can't have 4 because it's just less than 4. So at B, we're looking for actually having to write an inequality this time. So we actually have to find out information. So really, we've got minus 4 and we've got a 3. We know n is our number in between, but we need to know what's going on. Now, a hollow circle indicates that it cannot be that number. So n has to be greater than minus 4. But a circle that is filled indicates that it can be 3. So it can be 3, it has to be less than or equal to 3. So the next thing says solving 3y minus 2, which is greater than 5. At the first point, we've got to treat like it's an equation, okay? Treat this sign like it's an equation. So we've got minus 2. Remember, we have to do our keyword again, which is the inverse. So we've got to do plus 2 on both sides. We're going to get 3y on the left-hand side is greater than 7. So again, we've got 3 lots of y, but we only want 1 y. We need to know about 1 y. Okay, so we've got to divide by 3. So we've got y is greater than 7/3. Here's a cleaner version that you can watch at your own leisure. So, okay, now we've got one of our favourite questions to score marks on for all students. Okay, it's quite a regulation thing that comes on papers a lot, and hopefully you've actually learned it in class and able to see this, because it's actually been taken out with new GCSE, so you're quite lucky. So it says here we're looking for x cubed minus 6x equals 84. So we're looking for it as a solution of between 4 and 5, and we're using trial and improvement. We've got to get the answer correct to 1 decimal place. So we're going to start with, if they tell you this is between 4 and 5, you have to actually prove it as well. Remember that this is a comment section, so that's where we comment, and this is where we do our working out. That's where we do our working out. So you do 4. So first of all, you're going to do 4. So what you have to do therefore is 4 cubed minus 6 to the power, 4 cubed minus 6 times 4, which gives us a grand total of 40. Hence that this is too small. Then we do it for 5. We do 5 cubed minus 6 times 5. Remember that this 6 here is from 6 at minus 6x. So we have to minus 6 times whatever the value is of x, as we're substituting. So we're using substitution, for those of you who aren't aware. So that equals 95, which is, as you can see, too big. So already we actually get 2 marks just for proving what they've told us, which is quite straightforward in itself. As you can see, logically, it's a lot closer, 84, to this answer than it is to that answer, which tells me logically that it is closer to 5 than it is to 4. So what I'm going to start with is, I'm actually going to start with 4.7. This is what I actually did earlier. So I did 4.7. So 4.7 cubed times 6 times 4.7 equals 75.6. So 3 significant figures. So I'm always writing 3 significant figures. So that is too small. Still too small. So I think we got to do 4.8. So I do the same for 4.8 cubed, take away 6 times 4.8, which gives me 81.8. So we're getting closer. We are getting closer. So again, it's too small. So we do for 4.9. 4.9 cubed, take away 6 times 4.9 gives me 88.2, which is too big. Okay, so now we've actually isolated it that our answer must be either 4.8 or 4.9 because it's between the two. Now, just for inspection, you can actually tell that it's actually closer to 4.8. However, you need to prove that. So you need to go for one further step, which is actually in between 4.8 and 4.9, which is 4.85. So we're going to do 4.85. So 4.85 cubed, take away 6 times 4.85 equals actually 85. So you can see that is too big. So if we were to have on a scale 4.8, and we know that that was too small, we know 4.85 is also too big, and so was obviously 4.9 too big. That clearly says that our answer is between this little region here. That must mean, therefore, that it's close to 4.8. We're going to have to, because it's less than 4.85, we'd have to round off back to 4.8. So our answer is 4.8 to 1 decimal place. And here's a cleaner version for you all. So, next we've got one of our calculator questions, which for some reason, despite us being able to all wanting to use our calculators in class, this never seems to be a question that's answered very well when we actually look at the data of this actual school, or a lot of schools in general. So it is a question that we need to realize what we're doing. So I'm going to teach you how to do it so you make sure you're getting this right. So the first thing you do is you actually put 20.4 into the calculator. So that will give you an answer. So it's the right answer there. So I'm going to do it now, which is approximately 4.116 and goes on. But we're going to leave the answer in our calculator. At that point, you do the question. So you get answer and you can divide by, in brackets, 6.2 times by 0.48, close bracket. So we're dividing by what's on the bottom. And then when you read it off, you actually get the answer 1.517688. And this is for your bread and butter question that you have to get right. Because this is 2 easy marks for you, year 11. And I think that's what most of you should be out to achieve straight away. And that's the right answer. So have a go at this yourselves, and then I'm going to go through it. So, first of all, first and foremost, this one's a lot more actually straightforward because all you have to do is put 3.2 into the calculator squared plus the root of 7.5, which does give you a grand total of 12.9786127.9. Now, it says it wants to answer 2 significant figures. That means that we're only going to have 2 actual numbers there present which are significant, which means we have to get to the 3rd significant figure. Now, as you can see, that's a 9, so that's above 5. We're going to have to round up, so we're going to get 13. Next question says work out the value of 10 to the power of 5. 10 to the power of 5. Now, 10 to the power of 5, remember that 10 squared means 10 times 10, doesn't it? So if we got 10 to the power of 5, we're going to do 10 times 10 times 10 times 10 times 10. How many zeros we got there? We've got 1, 2, 3, 4, 5. Look at me counting backwards. So we've got that, there, and that. So it's 100,000. So we had 5 zeros. 1 times 1 times 1 times 1 gives us the 1, and then the 5 zeros. Straightforward that. As you can see. So, next question, again, same kind of thing in the calculator display. As I said to you before, find out the square root of 7,056, which is actually 84, and then do 84 divided by 0.35 times by 12.8, which gives us a grand total of 18.75. Correct to 1 significant figure. This time, then, you have to get to the 2nd significant figure, which is an 8. So as again, it's bigger than 5, so we're going to round it up, and it becomes 20. 20 even. Northern coming out there. So this is Pythagoras' theorem. Pythagoras' theorem. Yeah, so I've not actually been talking about some of these topics. So quickly, that was obviously accuracy and using a calculator and accuracy. Just going back quickly to say what some of these questions were for your notes. Again, that's the same. This was trial and improvement. This was inequalities. This was obviously just solving many equations. And then that was expanding and factorizing. So that's just letting you know what we were doing. If you need to go back and revise certain areas, obviously use HSC Maths and other resources. So question 10 is obviously Pythagoras' theorem. So we start with a squared plus b squared equals c squared. Remember that c squared is the longest side, which is hypotenuse. The longest side can be found by the side which is opposite the right angle. So it's always opposite the right angle. Always, c is always opposite the right angle. Okay, so what we need to do is 1.35 squared plus 3.25 squared, which gives us a grand total of 12.385. And we're going to square root that because that was c squared. So we need to get c. So c is the square root of 12.385, which equals 3.519. I think it continues, but we actually need the answer to three significant figures. So we need to know the fourth significant figure. And as that's bigger than 5, it is equal to 3.52 meters. Remember our units. Do not forget them. So here we've got a diagram that shows a prism. Work out the volume of the prism. So you've got to remember that the volume is equal to the cross-sectional area times the length. So that means we need to actually find out the actual area of this, okay? This actual compound shape. Easy way to do that is, let's split it. Let's actually split it there. So what we need to do is we need to do 7 times 4 because we've got a rectangle, which is 28 centimeters squared. And then we've got here, got to remember this left over is 5 because the bottom is 9, so that must be 5. 5 times 2 is 10 centimeters squared. Add the two together, 28 plus 10 equals 38 centimeters squared. And we need the length, which final bit of the puzzle, 38 times 10 equals 380 centimeters squared. Done. Cubed even. Cubed. Can't remember it's cubed, it's volume. Sorry. So, here we've got another one. Here's triangular prism. I wonder what we're going to do first. Again, what did I say before that we have to use? We have to use what was the formula I gave? The cross-sectional area times by the length. So we need to find the cross-sectional area. So the area of this. This shape is a what? Yep, a triangle. So we've got 4 times 3. So remember that is the base times the height divided by 2 for the area of a triangle. So times by 2. So that gives us 12 over 2. So 12 divided by 2 half of 12 is 6. So it's 6 centimeters squared for that area of the face. Then we've got to do 6 times the length, which is 20. 6 times 20. 6 times 2 is 12. Add the 0 on. 120 centimeters cubed. Done. So here we've got the nth term. Here are the first 5 terms of an arithmetic sequence: 3, 9, 15, 21, and 27. Find an expression in terms of n for the nth term of this sequence. So we're looking at the nth term. First thing we can do is we need to find the common difference. Common difference, as you can see, is 6. That tells us that in our actual nth term formula, 6n must be there. Now, I only learned a way a few years ago of actually finding out what must come here, because remember that this is 1, 2, 3, 4, 5. So we need, that's n, that's t. We need a way to get from n to t. So if we did 1 times 6, that wouldn't give us 3. So I was told a way, obviously, that go back to the start, almost predict that there's something before that. So if the gap was 6, the gap there has to be 6 as well. So we do 3 take away 6, which is minus 3. So 6n minus 3. Now you can see that works, because if we did 2 times 6, that gives us 12, take away 3 is 9. What about 4 times 6 is 24, take away 3 is 21. 5 times 6 is 30, take away 3 is 27. So we know, all right. Ben says 150 is in the sequence. Is Ben right? Well, the way to prove this is actually to use our formula we've got here and make this into an equation. So it becomes 6n. I'm going to use different color because I don't know how light that is. You can see it at home. So we need 6n minus 3 equals 150. So again, we have to do the inverse. So we've got to add 3 to both sides. which is 6n equals to 153. Now, you might have a calculator for this, so you need to know, or you might not, divide by 6, because that's the inverse. Now, I know dividing by 6, the answer is 25.5, which means, therefore, as it's not a whole number, that's not possible. So that means he is not in the sequence. It has to be a whole number when you find n, because you can't have the number, the 25.5 number. That does not work. So the next question we're going to go and do is, on the graph, draw this. So we're going to draw this. It says draw the graph of y equals 3x plus 2 for the values of x from -2 to 2. So what we need to do, first of all, is we need a little table. Hopefully you can see that at the top, everyone. And we need to have the values. So what we need to do is we need to put x, y, we're starting at -2, we're starting at -1, 0, 1, and 2. Now, I was told my class, the easiest thing to do is to substitute, because we're going to substitute here, is substitute into this equation. So we need to use 0. That's the easiest one to find out. So, because as this is 3x squared, sorry, 3x plus 2, that means it's linear. So it's going to follow a pattern. The gradient will stay the same of the graph. So 0 times 3, because it's x equals 0 at that point. So 3 times 0 equals 0. Plus 2 is 2. Next easiest one to do is 1. 3 times 1 plus 2 is 5. 2 times 3 is 5 plus 2 is 7. As you notice, this is actually going up by 3 each time. That's not right, is it? That should be 8. That should be 8. So we notice we're going up by 3 each time. So therefore, we need to go back there, and that would be -1. If we took the 3 away from there, that would be -4. So now we need to know to plot these. So we need to plot them. So I'm going to just draw a line here. You would actually probably nowadays actually get the actual axes drawn for you, so you wouldn't actually have to draw them. So that's a positive. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8. I'm going to actually not make it the same axis on both sides. So that's going to be 2. That's going to be -1. And that's going to be -2. And that's going to be -1, -2, -3, -4, -5. So 0. So we're looking at 0. So we're plotting there that. So 0, 2. Then we're going to go 1, 5, which is here. 2, 8. Then we're going to go -1, -1. And we're going to do -2, -4. So hopefully you're doing it as I'm doing it. As you can see, as it's a linear equation, we've actually formed a line, a straight line. Which you can see that. Just give you a second to actually note that down. So I'm back now, year 11. So we're going to move on to question 16 now. Actually, it's quite different. You can see this one says y equals 2x squared minus 1. And because it's slightly harder, they've actually filled into the table for us. And it's actually a quadratic graph, this one. So we're going to end up with something called a parabola, which you might have dealt with in class, but if you haven't, this could come from a calculator or could come from a non-calculator paper. Okay, so what you have to deal with, first of all, I would also go with 0. So it says here 2, 0, because we're going to substitute in squared minus 1. So 2 times 0, because obviously that's going to be 0 because 0 squared, minus 1 is minus 1. So we've got that, that's minus 1. Then we're going to do the same for 2, because remember we like dealing with positive numbers first. So 2 squared, because we've got to do brackets, remember, because big maths, is 4. 4 times 2 is 8. 8 minus 1 equals 7. Then we're going to do minus 1. So 2 times minus 1 squared minus 1 equals. So minus 1 squared. Remember, minus and minuses are plus. So we're going to get 1. 2 times 1 is 2. Take away 1 is 1. Now we're going to have to plot these. So, excuse me because I'm doing it on the computer. 0, we're going to get minus 1 here. 1 is going to be, sorry, it's 1, 1, isn't it? Yep, so it's about there. 2 is 7 all the way up here in the way of my 2, approximately. Then we got 1, sorry, minus 1 is 1, so it's up here as well. And then minus 2 is 7. As you can see, looking at this is quite symmetric. No, sorry, that's quite bad. I'm just trying to draw it properly for you all. It's kind of, it would be symmetrical. So I'm going to show you the proper version. Actually, that's already been done. And you can see there, it would be quite symmetrical. Now, it asks us to find out the solutions for the equation when it equals 0. So the solutions when it equals 0 is actually where it crosses the x-axis. So our solution is that point here and that point there. So that's where it crosses the actual x-axis. Those are our solutions. So where it crosses the x-axis, you find the solution. So approximately x equals minus 0.7 and x equals 0.7. Those are our answers. You want to look at that. That's quite a bit longer for you. But obviously you can watch this back and pause it and have a good look. Okay? So here we've actually got indices. You've got to remember what these are. So we start off with 7 to the power of 0. We should love questions like 7 to the power of 0 because anything to the power of 0 equals 1. So that is straightforward. Okay, 5 to the minus 1 is actually a reciprocal. That means we're actually flipping the number and it becomes 1 over 5. Okay, so for the same scenario, if we had 6 to the minus 1, that would equal 1 over 6. However, if we had 6 to the minus 2, that would be 1 over 6 squared. Now, what's 6 squared? That would be 1 over 36. So just be mindful of that. You might want to write that down as a note as well, because they could give you those, not just minus 1, they could give you negative 2, or even like minus 4. So 4 to the minus 3, which would be 1 over 4 cubed. And you're always meant to know 4 cubed is 64, so you should know it's 1 over 64. Okay? So here it is. I can't see the question around, so I'm going to look at my actual thing. It's 9 to the power of a half. So 9 to the power of a half. Anything to the power of a half means you're going to square root. So the square root of 9 is 3. Now, we've got here simplify a to the power of 4 times a to the power of 5. Remember, we're actually multiplying. We're actually adding 4 to 5. So what you're going to get is a to the power of 9. So for the same scenario, if you had b to the power of minus 3 times b to the power of minus 4, you are actually going to add these powers together. And remember what I said, even though you're adding negative numbers, it's going to end up being minus 3 plus minus 3, which means that's overall a negative. Sorry, it's 4, isn't it? So that'll become b to the minus 7, just so you know as well. Okay, the next question didn't actually print out very well looking at this. So I'm gonna write it out again for you. So you need to copy that down. So you're gonna have 45 e to the power of 6, f to the power of 8, and then you're gonna have 5 e to the power, sorry, e to the power of nothing, which is the same as e to the power of 1. You might want to write that in there. Not nothing, e to the power of, there's nothing there, so it's e to the power of 1. And then f to the power of 2. Now, again, like I did in the earlier question, I think it was question 1 or 2, I separated that. So you need to cancel down these. So 45 divided by 5 is 9. E to the power of 6 divided by e to the power of 1. You're taking powers away, so it's e to the power of 5. F to the power of 8 divided by f to the power of 2 equals f to the power of 6. Same question here, which obviously is above, so it's the square root of 9, which is 3. So I'd have all these examples too, because you will need them as well. Aim high, everyone. So here we've got question 19. Write 8.2 times 10 to the power of 5 as the ordinary number. So we're dealing with standard form here. Dealing with standard form. So what we have to do is we've got 8.2. Now what I do is I say, well, this means we're going to times by 10 times 10 times 10 times 10 times 10. I think I said it 5 times. So if you just do it once, times by 10 equals 82. So that means we're doing 82 times by 10 to the power of 4. So you can just add on the zeros. It's going to be 4 extra zeros. So we get 8, 2, 0, 0, 0, 0. Because you're adding on the extra 4 zeros because you're just timing by 10 each time. This one becomes a bit more tricky. Oh no, I've not done this one. B. Now B, there's plenty of ways to be able to do this, but I was also taught that this 3, because remember that for standard form, our values have to be bigger than or equal to 1, but it has to be less than 10. Okay, so this 3 needs to move to that position here in the units column. So it moves by going once, twice, 3 times, 4 times. As it's less than 1, we're going to, so as the number is less than 1, the actual proper number, we're going to 3.76. We get once, twice, 3 times, 4 times, times 10, so minus 4. Okay? So I'm going to rub this bit out here. We don't need that anymore. And we're actually more than halfway through. So if you've missed it, you're going to have to watch it again, I'm afraid. So we've got 2.3 times 10 to the power of 12 divided by, obviously that was all in brackets, divided by 4.6 times 10 to the power of 3. Can you see the relationship between this number and that number? Because 2.3 divided by 4.6, we're dealing with just those numbers. This number is half that number. So 2.3 divided by that equals 0.5. And then we've got 10 to the power of 2, so 10 to the power of 12, divided by 10 to the power of 3. Remember when we said we're dividing powers, that means we take them away. So it becomes 10 to the power of 9. Remember, we can't have 0.5. It has to be 5 because we want a number between 1 and not less than 10. So we have to get 5, but that means we're timesing this number by 10. So we lose one of our powers here. It goes down by 1 power. 10 to the power of 8. And here is the clean version, which you could do. I don't know why that says 5, it should be 6. Okay, here we're doing probability. So we've got onto probability now. So the probability that a biased dice will land on a 5 is 0.3. Megan is going to roll the dice 400 times. Work out an estimate for the number of times the dice will land on 5. So it's a biased dice which lands on 5 0.3 times. So that's the key part of the questions, and we're going to roll it 400 times. And if that is it, we're looking at relative frequency. We're going to do 0.3 times by 400, which comes to a grand total of 120. And that would be a straightforward calculation if you had a calculator. If you don't have a calculator, you're going to need to convert this into a fraction, so it becomes 3/10 times by 400. And then you can actually cancel that for that. So then you're just dealing with 3 times 40 divided by 1. Anything divided by 1 is itself. So 3 times 40 is 120 as well. Okay. So There are only red counters, blue counters, white counters, black counters in the bag. The table shows the probability that a counter taken at random from the bag will be red or blue. The number of white counters in the bag is the same as the number of black counters in the bag. Tanya takes at random a count from the bag. We'll get probability that the counter is white. So they told us that it's the same. So that means that these two have to be the same amount. So that means we need to work out what these add up to. And we know that all probability adds up to 1. So 0.2 plus 0.5 equals 0.7. So we have to do 1, take away 0.7, which gives us 0.3. So these two both collectively add up to 0.3. However, we know they're the same, which means that we have to divide 0.3 by 2, which gives us 0.15. Which means that the white counter is 0.15. It then asks us 240 counters in the bag, and that the fact that it still wants to know the number of red counters. We know it's 0.2, so again we've got to do 0.2 because 2/10 of them on the bag are red, so 2/10 of them are red, which gives us a grand total of 48. Now, again, if you don't have a calculator, that's 2/10 times 240. Get rid of the zeros. 2 times 24, 48. Hopefully that helps. Question 22. This is a two-way table. There are 40 people at the meeting. Each person travelled to the meeting either by car or by train. 13 of the people are male, 10 females travel by train, 8 males travel by train. Work out the number of people who travel by car. So you need to formulate a table. So what I'm doing is quickly just drawing a table, which you're going to need to draw as well if you're watching at home. And then I'm going to put information in, because it's best to actually work this information out from a table than actually trying to do it in your head and do calculations. It's so much simpler. So I'm going to label this males. So M, that's females. This is the total. So total, when we add them up, this is going to be the modes of transport. So we're going to have train, and we're going to have car. And again, we're going to have total. Now we know that there are 40 people in total. So the total, when you add up the total of car people who do car and train journeys, should be 40. For a total of males and females should also be 40. So we know that 13 of the people are male. So that means the total number of males are 13. Then therefore we can work out the total number of females, because we know 40 take away 13 is 27. So 27 females who were surveyed as well. 10 of the females travelled by train, which means that 10 were in this box. That means 10, obviously you need a number to get to 27, so 27 take away 10 is 17 in the car. 8 males travel by car. So we can find our answer now. We know that 5 therefore must travel by train. It really wants us to know how you travel by, how we travel by car. So it's 8 plus 17, which is 25. Obviously how we travel by train was 15, so we know that adds up to be the right answer. So we want this answer, and it's 25. So, favourite question to come out is actually questionnaires. Mason is doing a survey to find out how many magazines people buy. He uses this question on his questionnaire. How many magazines do you buy? 0 to 4, 4 to 8, 8 to 12. Write 2 things down, which is wrong with his question. Well, first of all, he doesn't say how many magazines he buys in terms of a time frame. Like, is it per week? Is it per month? Is it per year? Because if you ask anybody, they could tell you how many they buy in a month, or how many they buy in a year, or 2 years, depending on the kind of person. So you need to actually specify a time frame. Different color, different color. Now also you can notice that if I say buy 4 magazines, where do I put it? I tick in that box and that box. That doesn't help people. So there's overlap with the amount of boxes. Also, this is not exhaustive because what happens if I buy 13? Where do I stick there? Where do I put it? So 13 plus is not there, so it's not exhaustive. Yeah, that's the correct word. Write a better question. Ooh, so first of all, we're going to say how many magazines do you buy per month? So you could have a response box section, for example, none. So I'm going to just put these boxes. So you could have none, 1 to 3, 4 to 6, and then 7 or more. So as you can see, we've got a time frame. None's taken care of. We've got 1 to 3, 4 to 6, 7 or more. So that's what we've got. Okay. So you can see there's no overlap. It's a time frame, and everyone can ask the question. So we're done. Mason asks his friends at school to do his questionnaire. This may not be a good sample to use. Give one reason why. I'm asking how many magazines people buy, and all these children are the same age. So really, they're going to be getting pocket money or their spare jobs. So people spend a lot of money doing different things. So the likelihood they're not going to spend a lot of money on it, and also as they're from the same demographic, it doesn't read to a good sample size. So the key thing is that they're from the same demographic. You'd want a vast array of people from different walks of life. For example, old age pensioners, people who are going to jobs, adults, middle-aged adults, young adults, teenagers. You'd want a whole range of people to find out what was going on, not just the same demographic of people. As it says here, it's not a representation of the whole population. That's what I've just said as well. So here is can we label two things that's wrong with this? Okay, first and foremost, you can see that if I spent nothing on CDs, which I don't think a lot of people would buy CDs these days anyway, a lot of people download, so there's nothing. So there is no zero option, so no less than 10, for example. There's no less than 10. Let's just say there's no less than £10. Okay. Also, again, you can see if I've got 30, where do I put it? Or 50, where do I put it? So no. So there's overlap. Okay. So key things to work with. These are the common things again. Also, time frame. So these things are the 3 ones you always have to look for in the questionnaires. They will always be there. 2 of them will always be there. So that's 2 straightforward marks for you towards getting a grade C or B. Okay. Or above. Paula asked 100 people in the CD store to do a questionnaire. Her sample size is biased. Explain why. Well, it's clearly biased because she's actually buying CDs, and sorry, this is actually in a CD store about CDs. Well, clearly they're going to buy CDs. It's almost like going to a place of worship and then expecting other people to be there, loads of different people to be there of different faiths. Doesn't make sense. It's really not going to be a fair representation of what society is like. It doesn't make sense. So here we've got another favourite question, which obviously the examiners decided to take out, which is stem and leaf. But obviously will be in your exam, by the way, just not the ones of the years below you. So here are the heights in centimetres of 20 sunflower plants. And then we're going to order them for stem and leaf. Now, I was taught another method, which I didn't know actually a while ago, because I would normally just write them all out. I would order them up, because remember, they have to be in order. I'd order them up at the top, and then actually put them in. but a quicker method, which I was taught later on, which actually is a lot faster, is to just write them here in the order that they're given. So you start with 7, because it starts 7, 8, 9, 10. You're going to do a different colour, because remember that 10 is going to represent 100 in terms of our stem. So 73, 84, 78, 96, 98, 84 again, 101, 93, 71, 104, 81, 92, 95, 103, 100, 96, 87, 91, 88, 96. And then you can see these aren't in the right order, but we can put them in the right order here. So this is just our working out kind of zone. So we can do it here. Excuse me, just gonna have some water. So we've got 7, we've got 8, we've got 9, and we've got 10. So we can see we're going to order them. So it's 1, 3, 8. Here we've got 1, 4, 4, 7, 8. This one's longer. You have to be very careful with this one, because I had to count them out as well, because I missed 1, 6 when I did it myself earlier. So you just have to be very careful. So 1, 2, 3, 5, 6, 6, 6, 8. I was always going to forget a 6 again, so be very careful. Then you've got 0, 1, 3, 4, and we're done. Remember that one last thing we need to do is the key. So our key, for example, is 7/1 is equal to 71 centimeters. Okay, that's our key. Work out the range. Work out the range. Remember, the range is the highest to the lowest. So it's 104, take away 71, which is 33. The median height indicates that we need middle. So the easiest way to do is actually to slash through our numbers. So from the start to the end, 1 from the start, 1 from the end to get to the middle. And I'm going to do that. And as you can see, there's actually 2 numbers in the middle. So we need to do 92 plus 93 divided by 2 to find the average of those, and our answer is 92.5. Remember, if I'm going too quick for you, you can watch this back, and obviously it'll be available continuously at that same link that Miss Fine sent out in an email, so you'll be able to continuously watch it. If there's any questions you have to go over, also remember, let your friends know that this is going on, let them know you've watched it, so they can review it as well, and that they can use the packs that we've sent out, because it is a good resource to prepare for the PPEs, which, as you know, will be starting on leap year day on February the 29th in the morning. So our next question involves scatter graphs. To show the information about 8 people, it shows each person's height and the circumference of their head. I know this one all too well. So the table gives this information for 2 other people. So we need to plot these, basically. That's what it's telling us, isn't it? So we need to plot them. So we need to go through 180 to 72, because it says the height and circumference. So we go to 180, and we go all the way up to 72, which is about there. So then we need to do 170 up to 65. So 65 is here. I've done it. So we need, therefore, to then describe the correlation as it's going in that direction, where as this is increasing, so that means our correlation is positive. Remember that if it was going the other way downwards, that would be negative, but it's not. Sometimes you can have absolutely no correlation if it doesn't actually, the trend is not going in a certain direction. Draw a line of best fit. So obviously you need to get a ruler out, draw a line of best fit, and it has to go through halfway through the points. So you got half points on one side, half points on the other side. It doesn't have to go through all the points, because I know in science, I think they've taught you that they have to go through so many points. That's not how it is. That half point doesn't mean one side, half point doesn't mean the other side. So it actually is a direction and the trend of the actual data itself. So it then says estimate. So we got to estimate the circumference of a person who's got a head of 156 centimeters. So we go to 156 centimeters, draw a line to our graph, and then go across from our graph. So that's approximately 55, 56 centimeters. I got 55 when I did it in by hand, but it says 56 here, so we're going to go with 56. I think that's within the window what we've got actually from the exam board. I'm just going to check that. Remember, for all of these questions, we do have a window of actual accuracy, and the exam board says anything between 52 and 60, so it's quite large. But as I got 56, I was slap bang in the middle, so you can see mine was quite accurate. And so did Mr. Hecate get that. So, question 27 is cumulative frequency. The Greek frequency table shows the information about the weekly wages of 80 factory workers. So what we've got there is we've got all the wages, all the classes, and we've got the frequencies. So cumulative frequency means we're adding on, remember. So we've got to add on. So we've got 8 plus 15, which is 23. Add 30, which is 53. Add 17 is 70. Add 7 is 77. And add 3 is 80. And we know we're right because they said there's 80 factory workers. So we've done it right. 1 mark tick. Well done, everyone. So at that point, it says on the grid opposite, you need to draw a cumulative frequency table. Draw a graph, sorry, for your table. So we need to know what we're plotting for a start. So what you're plotting, remember, you have to know this, you're plotting at the end of each class interval. So you're going to plot 200, I'm going to use a different color because that's not standing out. 208. Then we're going to do 323, 453, 570, 677, and 780. So you have to plot the end. So you're plotting that with those values there. So that's going to be your X. It's going to be your Y. So we're going to go over to our graph and plot it now. So we're going to have to look at my sheet of paper as well. So 208. So we're about there. 323. I think it's there. I'm trying to be as accurate as I can because I'm looking at the computer screen. 453, which is here. 570, which is there. I can do that one accurately because it's 70. 677, which I think is about there. And then 780. So at that point, you need to draw a line. I'm trying my best. This one's come out slightly better than the last one. So we need to work out the information after to work out the interquartile range. So we need to work out our lower quartile and upper quartile. So the lower quartile is the lower quarter of our frequency, of our cumulative frequency. So that means our quarter of 80, which is 20, because 80 divided by 4 is 20. So we need to go across. I'm going to try and use a different color because this is not going to stand out very well. We need to go across and find out what our value is in terms of our graph. Then we need to do the upper quartile. So the upper quartile is 3/4 of 80. If a quarter of 80 was 20, we got to times by 3, which is 60. So we got to go across to 60. and go down again on our graph. So I've actually got approximately, I'm going to approximate, I'm afraid, because I think when I did it, I got 420 and I got 280, but I'll split that 270. So we'll just use 270 because that's what I got here. So what we need to do at that point is we should do 420 because the interquartile range is the upper quartile. So the IQR is the upper quartile, take away the lower quartile. So we do 420, take away 270, which equals 150. And checking the mark scheme, we are allowed anything between 120 and 160. So we're within the region. So the last question says, use your graph to find the estimate of the number of workers with a weekly wage of more than £530, £530. So again, we need to use our graph. So we need to find out how many workers are above £530. We go up from our graph, and go across. And you can see that is approximately about 73. So 73 workers have got less than 530 because the rest of them at that point are scoring more than that, between 530 and 700. So that means that we're going to have to do 80 minus 73. So we've got 7 workers, and it allows anything between 6 and 9. Brilliant. So the next question, so we said you got 8, I got 7. The next question says find the cumulative frequency, the median, use the graphs to find the median and the interquartile range. So to find the interquartile range and the median, we need to actually find our upper quartiles, our lower quartiles, and the median. So remember that the upper quartile was 3/4 of going to be of 20 because that's our cumulative frequency times 20. So 3/4 of 20 is actually 15. Our median is half, remember, because that's the middle numbers, half of 20, which is 10. Our lower quartile is actually 1/4 times 20, which is going to be 5. So we have to use our line to go through and find this information out. So we're going to go through, and 15 is there. Now on this, again, this is more accurate because they drew it themselves. So you're going to have less windows to make mistakes. So you have to be very accurate with what you're doing here. And I'm going to try and accurate as I can see it on there. So what we've got here is, as you can see, it actually is 10 squares to 20 units. So that means that every square is worth 2. So as you can see there, that's 56, and that's 56 for the upper quartile. For the median, that is 46, and for the lower quartile, that's 30. Almost looks like it's 30. I think it's 30. So the lower quartile is 30. So for the median, we've done that. That's 46. The upper quartile is a low quartile. Upper quartile take a low quartile, so it's 56. Take away 30, which equals 26. So we've done those now. That's quite straightforward. I'm hoping that people can actually do that from now on. And it is 26. So B says, Mr. Wilson's class is the same as Mrs. Angus's class. This is Mrs. Angus's class. So I love doing comparisons between a box plot and the frequency curve. Mrs. Wilson's class did the same maths test. The box plot shows information about their marks. compare interquartile range of Mr. Wilson's class with interquartile range of marks on Miss Angus's class. Now, a lot of times actually they will just tell you to compare, so you're going to have to be able to compare yourself. They won't actually tell you what to do it with. So they've told you to compare the interquartile range. Now the interquartile range here is, the lower quartile is here, the upper quartile is there, and so you have to look forward and see what you can see here. Now the gap here, as I can see again, is actually 2 units for each square. So I think that, looking at my sheet of paper here, is going to be 64. And then that one there is going to be 28. So you can see that to find out the upper quartile, take away the lower quartile, 64, take away 28, which equals a grand total of 36. So you can see that the interquartile range of Miss Angus's class is actually larger. So the interquartile range of Miss Angus's IQR, sorry, is actually smaller. It's smaller than Mr. Wilson's. So, for this information, I don't know why it's not actually there, so I'll just do it again. Some girls in a sponsored swim to raise money for charity. The table shows information about the amounts of money the girls raised. Now, this has already been pre-drawn, so you can see what you need to do. It says the least amount. So the least amount is actually done here. So the least amount is actually the tail. And so is the maximum amount. The greatest amount is also the tail. Now, as for the last example, the upper quarter where the box, sorry, the lower quarter where the box starts is drawn here. So that would be, if we're looking, and this one is every unit represents a number, so that's 16. Now the median is given by the line which actually crosses the box, which at this point is 25, which says here. And then the upper quartile is 42. So you've got those now. Now it asks you at that point to actually compare what's happened with what the boys had raised in the sponsored swim. Okay, so the boys, you've got to look at the greatest value. So the greatest value, you can look at the greatest value. Sorry, this is the smallest value. I don't know why it's the greatest value. So the smallest value is £5. The lower quartile is £18. The upper quartile is £40. The median is 32. Now, when they ask you to compare for these 2 marks, they always expect you to compare the median and the IQR, the interquartile range. So the median is 32. So that means that the boys had a higher median than the girls. And then you got to look at the interquartile range. So interquartile range here was going to be 42, take away 16, because it's the upper quartile, take away the lower quartile, which is 26. Here, it's 40, take away 80, which is 22. So the boys also had a lower interquartile range. The boys had a lower interquartile range. So there we have it. Okay, so the next question says the table gives information about the speeds of 75 cars on a road. So the speeds are given. Work out the mean speed. Now, it seems to be there's an issue with what should be here. So I'm assuming that this should be less than 40, that's less than 50. That's less than 60, and that's less than 70. Straightforward, just add those in. So we need to find out an estimate for the mean. Remember that basically what they found out is between 30 and 40. We don't know the accurate values. This is group data. We need to know that we would need to know the raw data to give an accurate amount, but we're actually going by an estimate. As an estimate, we need the midpoint, like the average between each of these class intervals. So we got the midpoint. The midpoint is between 30 and 40 is 35. Midpoint between 40 and 50 is 45. Midpoint between 50 and 60 is 55. And between 60 and 70 is 65. Now at that point, obviously this is our average, but this has happened 7 times. We're going to use this times by our average for each of those classes, which is 22 times 45, 34 times 55, 12 times 65. So we're going to do F times MP, which is obviously our midpoint. So what we need to do is 7 times by 35, which gives us 245. 22 times 45 equals 990. 34 times 55 equals 1870. And 12 times 65 gives us a grand total of 780. And we know that there's 75 cars on the road, so that should all up to 75. Remember, we've got to divide by a total frequency. Like if you're doing enemy, you're dividing by how many times you've done it, how many numbers there are, so there's going to be 75. So we have to add up all of these. So that's going to be giving us our estimate. So we've got 245 plus 990 plus 1870 plus 780, which equals 3,885. So to do 3,885 divided by 75 to give us our estimate. This equals 51.8. So I hope that's the same. Oh, I forgot one thing, didn't I? My units. Do not forget your units. Do not forget your units. Sorry, I just had Mr. Reeve knock on my door. So, question 31. The table gives information about the temperature T Celsius at noon in a town for 50 days. So again, we need to actually have the midpoint. This is an estimation. I've jumped the gun. They've not asked us for that yet. Jumped too quickly. So that's where you always have to read the question. It actually asks for my overall class. And these are all class intervals. So group data, which is the most frequent, we look down our list, and 21 is the most frequent. So we know that it's 20 is less than t, t is greater than 20 or less than or equal to 24, sorry. So we're told to work out an estimate of the mean, so we need to find our midpoint again, and we're going to also do our F times MP. So our midpoint there is 10, between 12 and 16 is 14, between 16 and 20 is 18, between 20 and 24 is 22, between 24 and 28 is 26. So 6 times 10 is 60. 8 times 14 is 112. 13 times 18 is 234. 21 times 22 is 462. Then we do 2 times 26, which is 52. So remember, like what we did before, we have to add all our figures together, which gives us 50. And we have to add our F times MP, which gives us 920. So 920 divided by 50, we can cancel off the zeros, and it's 90 divided by 50, which is 18.4 degrees Celsius. Didn't remember my units there, but they are there anyway. And that's how we would do that question. Here comes the bit which we need to do, which is the frequency polygon. Okay, the frequency polygon. Now, a frequency polygon is actually plotted using the midpoint and the frequency. So we need to know the middle point. So our midpoint there is 10, and we go all the way up to 6. Remember that this is obviously, again, you need to look at the scale each time, because this is up 10 squares for 5 units. That means that 2 squares are worth 1 unit. So there is our 6. Then we're going to go to 14, and we're going to go up to 8. Then we're going to go to 18, and we're going to go up to 13. Then we're going to go from 22 up to 21. I'm going to be trying to accurate here, but I'm struggling to see it properly. They all look quite similar. 21, so that's about right there. And 26, which is 2. Why am I going all the way at the top? So you have to connect those. And this is actually a straight line exercise. Okay, so I've connected all the points here, drawing my frequency polygon. You could start and have a box as well, like a bar chart. So there are my answers, just quickly neatening up how to do it. I'm just going to check. 920 divided by 50 equals 18.4. This is not correct here. It's 18.4, not 18.5. So, Ali has 2 solid cones. This is similar shapes, everyone. Ali has 2 solid cones made from the same type of metal. The 2 solid cones are mathematically similar. That's the indication that we are dealing with similar shapes. The base of the cone A is a circle with diameter 80 centimeters. The base of cone B is a circle with diameter 160 centimeters. Ali uses 80 milliliters of paint to paint the cone A. And then Ali is going to use paint B. So, as he's painting the actual cone, he's actually painting an area. Okay, he's actually painting an area. But we actually need to find out the scale factor, how much it increases, okay, from A to B. Now, in terms of for length, it's going to be 160 divided by 80, which is 2. Okay, but that's the constant for K. When we're dealing with area, K has to be squared, so we're going to do 2 squared. When we're dealing with upscaling, say volume is, remember, it's cubed, so it's K cubed, so we're going to deal with 2 cubed. 2 squared is 4, 2 cubed is 8. As we're working out here, this is work out the amount of paint we're doing, so remember we're doing an area. So if we had this, we know it's 80, it should be 80 times by our actual scale factor for the area, so times by 4, which gives us a grand total of 320 milliliters, because it's painting an area, so 80 times 4. It then tells us the volume, excuse me, of a cone is 171,700 centimeters cubed. Work out the one with cone B. Well, we said that K cubed was going to be 2 cubed, which was 8. Therefore, we're going to need to do 171,700 multiplied by 8. So I'm going to put that into my calculator right now. So obviously you would have a calculator for this. And that comes to 1,373,600 pounds. That would be a lot of money. So that's 70 meters cubed. If only we had that money. So here we've got that. Just a quick method. And there we go. So here we've got stratified sampling. So stratified sampling is something you can check on HSC Maths as well. That's up and running. The probability section, the statistics section is all up and running now. So you can use that to the best of your ability. So it says here, the table shows information about the ages in years of 300 students. Quite lucky, because normally they do get you to actually add up the number of students yourself, so they've actually told you that. And it says index sample of 50 students, so key bit is 50 students, there's 300 students in a sample. And he wants to calculate the number of 16 students he should have in his sample. So we know that 68 were sampled, or actually, sorry, in the school. Remember that is proportional. The sample size is taking has to be proportional to what's actually existing in the school. The strata existing in the school. Each strata has to be proportional to what you have in the school. So we're going to have 68 over the total, which is 300, and we're going to multiply that by 16. Putting that into my calculator, you actually get 11.3 reoccurring, which means that you're going to need 11 students. Now, be mindful that sometimes they might get you to check a few, because you might end up having to round this up at certain occasions if they ask you to check more than one. So be very careful. In this instance, they don't want you to, and they have actually accepted the answer 12, but the answer is 11. So, you know, think about this. If they want you to go through and check all of them, check them and see that they all add up to the 50 students you need for the sample. Okay, if you have time. So here is our final question. I might go back to some if I've been a bit quick, because I think a few of them I was a bit fast. Just a quick look if you're not sure. Let me know in the comment section anything you want to look at quickly again, and I'll happily go through it with you again. Because we've been quite common on the comment section. I haven't actually seen a lot, to be honest. But let me know any questions now. Look through, so we do have another 25 minutes. Look through, and I'll happily go back to it and explain it again if I was too quick the first time. So we've got here Jeremy's socks. He's got 10 socks. He's got some red. He's got some blue, and he's got some green. Now, we're going to have to work out, so he takes 2 socks at random. taking 2 socks at random, and we have to work out the probability that he takes 2 socks of the same colour. So i.e. we need 2 red, 2 blue, or 2 green. So first of all, you also have to remember that as he takes the 1 sock out, he's got those sets of socks already, so he now has less socks in the bag, so it's without replacement. So at the second iteration, it's the second time taking socks out, he would only have 9 socks. So we're going to deal with, first and foremost, red, blue, green. So we have to draw a 2 diagram. This is red, this is blue, this is green, red, blue, green, red, blue, green. So the probability of red here is 6 out of 10 because we've got 10 socks. It's 2 out of 10 here and 2 out of 10 there. Now if we take red and then we want red again, we've only got 5 now remaining out of 9. But however, we've got 2 out of 9 of blue and 2 out of 9 of green. Remember that when you add probabilities together, they should all add up to 1. So 5 over 9 plus 2 over 9 plus 2 over 9 is 9 over 9. So we know that's 1. Also 6 over 10 plus 2 over 10 plus 2 over 10 is 10 over 10, which is 1. So on this one, it is not the same as that because we've now taken out a blue one. So we still have 6 red ones out of 9. For this one here, we have taken a blue one, so we have 1 out of 9. For this one, we've still got 2 green ones, so we've got 2 out of 9. Now for this one, we're taking out a green one. So we've got 6 out of 9 red ones remaining because at each iteration, remember, we're just deciding what we're taking out here, which is a green one. So we've taken out green. These are all separate branches that we're dealing with, probabilities happening. So we've got 6 out of 9, we've got 1 out of 9, and we've got 2 out of 9 there, and we've got 1 out of 9 here. So green, green. So what we can do is we can write our probability. So for red, probability of red is going to be 6 out of 10 times by 5 out of 9. The probability of red, blue is going to be 6 out of 10 times 2 over 9. Probability of red, green equals 6 out of 10 times 2 out of 9. Probability of blue, red is going to be 6 out of 10 times 2 over 9. Probability of blue, blue equals 2 out of 10 times 1 out of 9. Probability of, I've done this wrong, haven't I? I've done it wrong. There's a mistake, everyone, here in this column here. It should be here, BR, which is 2 over 10 times 6 over 9. And this one here is blue, green, which should be 2 over 10 times 2 over 9. Then we're going to do the final 3. So it's going to be green, red, which is going to be 2 tenths times 6 over 9. Green, blue, which is 2 tenths times 2 over 9. And we're dealing with green, green, which is 2 tenths times 1 over 9. Now, when you add all these up, I think you'll see on the following slide, when you add all of them up, they should add up to 1. Okay, everyone knows it should add up to 1 because obviously it adds up to 1. But we're only interested in where we have the same socks. So we need that one, we need this one where it's blue, blue, we need this one where it's green, green. So red, red, so we're going to do 6 over 10 times by 5 over 9, which actually equals 1/3. Then we need to do BB, which is going to be 2 over 10 times 1 over 9, which is 1 over 45. And then that one, which is going to be, again, 1 over 45 simplified, because 2 times 1 equals 2. 10 times 9 equals 90, so 2 over 90. Divide the top by 2, divide the bottom by 2 is 1 over 45. So we have to add these up, because that's the probability. We have to add them up, because we're adding the scenario of getting red, red, blue, blue, green, green, because those are scenarios where we get what we want here. And then we get 17 over 45. And that's that. So I'm now going to go back and look at anything that you've had any issues with, because that is actually the last question. I'm going to quickly show you what Mr. Hegarty had done already, so it's quite a lot neater in terms of that. Now he's got 34 over 90, but I've simplified it. And obviously I divided that by 2, which gave me 17. Divided that by 90 by 2, which gave me 45. And that's how I got them, okay? So now I'm going to actually focus on anything that you've had an issue with. And I'll see anything else. So year 11, I'm currently getting any sort of feedback, because I can't see the chat. I've actually been looking and I haven't been able to actually view anything. So I'm getting feedback in terms of any questions you want to go over in the next 15 minutes until we stop the webinar. Oh, I can actually see now actually on the video. So I can see Tyra saying 23. Anything else? It's the middle number. Good explanation, Renee. I'm just looking. The sound is slowed down. 33. Thanks, Miss Hale. So, apparently we got question 33. I don't see any more, so I'm gonna 43 for the median, Amy. I think that should be fine. Right, I'm going to do question 33. Look at that again, because Tyra's asked to see that again. So I'm going to look at that one quickly now. So quickly to start off with, again, Tyra, and anyone else who's unsure of this question, we've got there all of our, sorry, 1 second. We've got there 300 students. Now, they've given us the 300 students from who are 11, 12, 13, 14, 15, 16. You can check that all of these should add up to 300 when you add up all of these numbers. Now, in terms of stratified sampling, it matters that when we're getting a sample of 50, it's proportional to the number of students we actually have in each age group. So we need to have 68 of our total out of 300, and then multiply that by the 50 we've got in the sample, which comes to 11.33. If you're not sure, put your calculator. It's the second, but it's the below shift. It's the second button below that. Put that in. Put 68 out of 300, and times by 50 afterwards. Yeah, when you move the arrow, and that's going to be 11.33. And that gives you, that's 11 students. Okay, any other questions? Yeah. Any other questions? Number 12, Ahmed. I don't know how I got 11.3. It's 11.3, Majid. Amy, what's your question? Any more? Anyone else got anything, actually, before we sign off in 12 minutes? It's better you can just ask us now. What's the mistake, Majid? Okay, Amy. Majid, it has been rounded. You have to round it to 11. Now, in the case of actually going through, as I said before, if you had to actually analyze more of these actual strata, which means each individual age group for 12, 13, 14, you might actually end up with it being short of 50, where you might have had to round up to 12. But at the moment, as we haven't been told really to do that, we have to round down to round off back to 11. And that's what we're going to do. You can't have 11.3 students. You can't have someone, with just an arm or a leg. They have to have a full body. So it has to be 11 students. So Amy, your question referred to the upper and lower quartiles. So upper and lower quartiles, remember, you remember that we have to find out the interquartile range, we have to do the the upper quartile, take away by the lower quartile. Okay, so in this scenario, if they gave us that, we know it's 42, take away 16, which obviously gave us 26. So you have to be able to do that. Now, also remember that I'm going to add an extra slide. If you have to work it out for the cumulative frequency, you're going to have for the upper quartile, you need to know what 3/4 of the CF is. And for the lower quarter, which is probably easiest to do first if you haven't got done the median, is going to be 1/4 of the CF, and the median is half of the CF. So, for example, half of the CF. So, if the cumulative frequency was 120, for example, you could work out the median would be half of that. So, half of 120, which equals to 60. 1/4 of 120 would be the lower quartile, which is 30. And 3/4 of 120 would be 90. Now you would have to go, therefore, if you had a graph. Sorry, this is kind of, I'll just do it again. If you had a graph, and say the graph went up, like that, for example, it wouldn't, but say it went up, you would have to go to 90 on your graph. So this would be our CF, cumulative frequency, up to 120. You'd have to go to 90 on your graph, you'd have to go to 60, you'd have to go to 30 to find these information out. So you'd have to go across and down to find out what it was here, and then across and down to find out the median there, and across and down to find out the lower quartile. So I'm just going to give you random values here. So for example, that could have been 70, that could have been 38, and that could have been 29. So the median, therefore, would be 29. The upper quartile would be 70, and the lower quartile would be 20. So the median's 38, isn't it? And the lower quartile would be 29. So to work out the interquartile range, we would need to do 70 minus 29, which gives us a grand total of 41, okay? So hopefully, I hope that helps a bit. Any more questions? Any more questions? So, Majid wants us to repeat question as it starts. Unfortunately, the Hangout has now actually stopped sharing, so I'm going to have to go. If you need any extra assistance, you can come and see us at lunchtime tomorrow, or find a teacher at any point. Thank you very much for listening. I hope it's been worthwhile. Remember what we said, you can always watch this again. The link will be the same, it's going to stay up there on my account. There is an A Start A webinar on Thursday for those of you who are watching that. There is also a foundation webinar on Thursday. We have got the walking, talking mark coming up for all of year 11 in a few weeks' time when you get back to preparation. Remember, the only way to revise maths is by practicing maths. So you need to start practicing as much as you can to get as good as you can. Okay? That's what you need to do. Practice makes perfect in a day. You can't just get better at maths by just reading it. You have to practice questions. If you need help, come to the teachers. The teachers will help you. That's what we're here for. So you've got to make sure you're making the effort to get as high on these PPEs as you can, and going forward, obviously, to your GCSEs on May the 26th and June the 9th. This is Mr. Ejiofor. Thank you for watching. I'm going to stop sharing now and have a nice evening. Oh my god. Oh my god. What a god now. What a god.